Hey there, my name is Chris Dale, and today we're doing overthewire.org's war games, specifically the Natas web challenges. It's all about web hacking, and we're on Natas11. So we've already done 11 more levels. We're on the 12th level now, even though it says Natas11. It actually starts on Natas 0, and it's getting progressively more and more hard. In this case, we have some clues here. Cookies are protected with XOR encryption. Ooh, fancy. Much secure. Cool, cool. And it looks like we can change the background color. So that's going to be white. Can we set it to like black? Didn't look like 1, 2, 1, 2, 1, 2. And yes, we can change and interact with this script. And it says cookies are protected. So we're going to have cookies here then probably. So it says so down here we have the data, a data cookie, which has the following value. Let's take a look at this value in Notepad. So definitely looks like base 64 to me, based on we're seeing A to Z lowercase characters. We're seeing uppercase A to Z more or less. So we are also seeing numbers. So we're going to see 0 to 9 in base 64 strings, and we have this %3D. No, I don't want this to throw you guys off. %3D looks like URL encoding. I mean, to safely transfer some special characters across HTTP, we need to encode the characters so they do not interfere with the HTTP protocol and more. So whenever you see percentages within web stuff, it might be URL encoding, and %3D is very often an equal sign. I mean, that's what it is when we are doing basic 64 decoding. So let's use CyberChef again. Do a URL decode, and we can see that %3D translates into equal sign. Now it also said it was protected with XOR. Let's do a basic 64 decode here. Now this is not something that we can easily understand, right? It looks to be encrypted, and in fact the website says that it is encrypted with XOR. So the cookies are encrypted, which is cool. I mean, this could allow us to start fuzzing this cookie now and try to manipulate the output and see what happens. A cookie value, so the background color seems to be what we can change here, but the background color, like if we open up another CyberChef here, look at this. This is the value for background color. If we base 64 encode this to base 64, this is by far not the full URL. I mean, the full value. Our value is much longer. So we have to guess that there is something more inside of this string here that in some way, shape, or form will reveal secrets of to allow us to get to the next application here. Of course, we could start trying to hack it with like special characters, try to force some error messages, just try to see if we can make the application misbehave. But what I like about Over the Wire, and especially the Natas war games, is that they allow you to view the source code without giving you the password for the next level. That way, when we're trying to learn, instead of like foaming in the dark and trying to find our way with all kinds of different attacks, basically guessing and guessing and guessing, sometimes even for days, instead they allow us to inspect and see what's going on and see if you can break it then. It's kind of like an open source type of thing, right? So the source code up here we don't care about. It also says so in header up here. This stuff is header stuff. You can ignore it safely. We are primarily interested with the PHP code, which is in fact quite a bit of PHP code. Now we have some default data, has an array, show password equals no. So this show password is an array with where you can specify the key as a string, and the value of show password is no, and the color is FFF. So this is what we started out with. Then we have the XOR function. It's gonna XOR a key which has been censored to not break and spoil the challenge. We're gonna take the text value from the input here, and we're gonna go through each part. So for each part of the text, so for each part of the input, we're going to concatenate to the out text. For each part of the input, we're going to XOR. This is designed for XORing. We're going to XOR it with the key at the following location. And here we can see, well, actually, the key at the following location modulo string length of the key. So this is basically gonna repeat XORing over the key over and over and over again as long as we are lower of the text, the input size. As long as we are not reached the maximum size of the input size, we are gonna repeat the key and we're gonna XOR it. So that is quite interesting. Whenever we have repeating keys with XORing, that tend to bring up vulnerabilities. So this function is just going to return whatever has been XORed. So XORing, encryption, and decryption is basically the same function. We then have the load data function, which was, okay, so it's being run here. So global variable cookie. My data is being put in from the def here. If array key exists, all right, so this should exist in every request because we are sending the data cookie in. If it exists, which it does, we are gonna put the temp data to the value of JSON decode, cool, XOR encrypt, which is basically decrypt, base64 decode, all right, so back to CyberChef then. So they're gonna decode this. Notice that they don't have to do URL decoding because the web server will actually do this for you. So base64 decode that and then run XORing. And we don't have the key. Now, if a temp data is an array, which it should be unless we mess up the cookie too much. If we tamper with this cookie and it's no longer an array, this will not work. So if it's an array and the array has a key called show password and it has a key called bgcolor, so this is by kind of making sure that this array up here is actually in pristine order. It's not been tampered with too much. Then it's going to run the following things. It's going to make sure that the color is actually 6 characters. So I actually failed on this one. The first try I had, I only had 5 bytes of color. You need 6 bytes of color as indicated with this regex. And if the color has been set, we are going to put show password into my data and also the bgcolor. Cool. So that's that function. Then we have a save data function, which is basically what happens when we set this color, I believe. And we have if array key exists, bgcolor request, preg match, 6 characters, yes. So this will save it. Now, nothing that reveals the password yet. However, it has this little show password equals no, so that's kind of a giveaway, right? But here we have some more code. Here, if data show password equals yes, then we get the next password, which has been censored. Okay, so that is the challenge. So it's a kind of interesting challenge, and we're probably going to spend more than a few minutes on this one. XORing is nice because XOR can both encrypt and decrypt, and the nice thing about XORing, let me show you. So we have 3 parts of an XOR cipher. We have a key, for example, ASDF. We have a ciphertext, which is the garbage that you saw in CyberChef. So basically this. So this is ciphertext, and then you have the clear text. The nice thing about XORing is that as long as you have any 2 out of these 3, you can reproduce the last one. So if I take the ciphertext and XOR it with the key, I will get the clear text. If I have the clear text and I have the key, I XOR these together, I will have the ciphertext. I have in my script here default data. If I go through the function, I can see the set cookie actually XOR encrypts and base64 encodes and JSON encodes the this variable here, %d. So whenever save data is called, where is save data called? It's being called down here. So every time the script is run, it's going to run save data. And the data field, so let's look at the data here. Control F. So searching didn't work anymore, but let's see where we have the data equal. Oh, there we go. Data equals load data. Load data equals my data, blah, 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 returns my data, so it returns this. So it seems like this being called with a default value. That's fine. And yes, it has the same function again. So we have this interesting array here that we basically need to, we want to be producing this clear text value here. We want to produce this clear text value. If we can produce this clear text value and XOR this with this, we can get the key. That's what I tried to explain before. But the clear text value, we cannot take this value up here because this is actually PHP code. This is PHP code. This will not work. If we start XORing those together, that will not work. We need to do a JSON encode. Now this is where it gets interesting. Let's go PHP, run PHP online. I can't remember all those. Google.com. Run PHP online. So write code online, write PHP online, cool. So echo hello world seems to be working. So let's do a JSON encode on this data, on this array, because we want to produce something that might be representative of clear text. Run code. Maybe add an echo before, so we actually get some output here. Yes. This looks like a JSON array. Now you could write this by hand, of course. I mean, you could have just converted that array to JSON yourself. I mean, didn't we have like this array in here somewhere already where we had this string? Anyways, I like to simulate the target environment to my best ability. If my target is running ASP, I want to be running ASP. If my target environment is running PHP, I want to have a PHP interpreter so I can learn, so I can fully understand what's going on here. So with this output, show password no, bg color FFFF, that looks like something that could be of a clear text value here. So show password no, this is a ciphertext. So in theory, with XOR, if I now take my clear text, so we learn about the clear text from the application itself. So this would be hard to guess if you didn't have access to the source code. This would be hard to figure out this associative PHP array, figure out the different values, know that there's some JSON involved here and so on. That would be hard. But since over the wire and Natas is all about learning, they give us a source code and we can be more surgical in our attacks. So let us take this, let's move output to input. So we have this bytes of ciphertext up there. Let's do an XOR. Nice, really nice with CyberChef. Let's add this value up here. It's not hex, it's basically UTF-8. Woohoo! Look at this. So we input our little key. So we're going to XOR this value up here, these bytes. We're going to XOR it with the ASCII string, UTF-8 actually, of show password no. And look at this output. This is no coincidence, my friends. This is a repeating key. QW8J. QW8J. This is the weakness of XOR. Unless the key is the same size of the ciphertext, this will become a problem in many, many applications. So we now have a repeating key in our output. So let's then do, let's go here, let's XOR, let's now XOR this, XOR it with UTF-8. We can now change from show password yes, no to yes, same BG color, doesn't matter. And we could do, didn't we have to do, let's see, didn't we have to do a base 64? So we take this, we do a base 64 encode and then XOR. So we're going to repeat this. So we're going to do JSON encode, we're going to do XOR, and then we're going to base 64. So let's see. I think we're going to do it like this. Save data. We're going to do base 64 encode, XOR, and then we're going to do, okay, so let's do here. Actually, I don't like this. Let's do it like this. So our input is that, and the key is this. Much better. And then we do base 64. To base 64. Very much like this string, because look at this string. Look at this string. Starts with the same as the one I had. It does not end with the same, but as long as it starts with the same, I know that we have the curly brackets and everything looks good. I don't need to do any URL encoding here, I think. Let's see what happens when we overwrite this cookie. Press F5. And hey, the password for Natas11 is... So, that's XORing for you. Key takeaways, I would say, is know that XOR is inherently quite strong unless the key is shorter than the cipher you are trying to break. If it is shorter, you have to repeat the key. You have to repeat the key. That is what they're doing in this piece of the source code here. They're XORing each character of the input with each character of the string, and they're repeating the key. They're looping over the key over and over and over again. In this case, the key was only 4 characters long. 4 characters long. This is the key. It's being repeated over and over and over again. This garbage at the end is because our input, and compared with our key here, they're not identical in size, so we don't have to care too much about that. Nevertheless, we did get the password. Let's see if this works, so we can move on to the next video. And there we go. Oh, file uploading. I bet you this one is going to be interesting. I'm going to save this one for our next video. I hope you guys will stay around. And I'm Chris Dale. I hope to see you in my next video, and I hope you liked it. See you later.